And thanks for inviting me. It's always fun to give a talk on a topic when nearly everybody in the audience knows more about it than you do, and that's the case with coral reefs. So I thought I'd double down, and rather than do something like valuation of coral surfaces, where I could probably done a fair bit on that, I'd speak on a second topic in which, again, more people in the audience know about than I do, and that's resilience, which I think is a central concept in management, but also one that needs a lot more exploration, and one where I think some perspectives from economics and decision theory, areas I have worked in, I hope will turn out to be helpful. So that's me. You can check my website, so I assume we'll get this on the thing, but Google will do the job if you want to find out more about what I've been doing in various topics. Mostly until recently working on the economics of the Murray-Darling Basin and the New Federation Fellowship. I've seen a lot of commonalities in the kinds of problems that are emerging there and those of the Great Barrier Reef, so I'm hoping to extend some of the ideas I've developed in that work. So coral reefs are complex systems in all sorts of ways, and this issue of complexity makes it difficult to apply certain sorts of traditional analytical tools, concepts of stability, for example, and equilibrium that economists and engineers are very familiar with, don't necessarily work quite so well with these sort of multi-scale systems. You have at most a dynamic equilibrium concept rather than a system returning to a stable equilibrium. And an area I'm particularly interested in is complexity and irreducible complexity. We can't aspire to a complete knowledge of everything that's going on in the system. It always has the potential to surprise us in various ways, and the question of how we can make decisions faced with that kind of irreducible complexity is a big interest of mine. So economic importance, of course, Terry's already mentioned this. Fishing, both subsistence fisheries, which are the major source of protein for large numbers of people in the developing world. In the Australian context, commercial and recreational fisheries are also a big deal, and something that's under severe stress. Tourism is a large and growing source of revenue derived from coral reefs. Again, we can get different estimates of the value of these things. Then I think it's important to, while we can certainly get numbers for these things, and they are useful for some analytical purposes and also useful for some rhetorical purposes in pointing out, particularly going back even a decade or two, quite very short-sighted proposals for very limited sorts of exploitation of reefs in very destructive ways that have only been off the agenda in Australia for the past 30 years and are still, of course, very active in many countries with coral reefs. But the importance of reefs as a source of scientific knowledge, both directly useful knowledge but also value in itself, and the value that people, particularly people in developed countries, place on biodiversity and just the aesthetic values of coral reefs are highly important. Now, there's a bunch of controversy within the economics profession about how you can value these things, whether indeed you should. I tend to lean to the view that most of the time placing dollar values on these kinds of things isn't an incredibly helpful thing to do. But equally, it's important to recognise that this is a major driver in policy decisions, that people care about these things and they expect that care to be reflected in public policy. So these values are all under threat from a range of sources, which we've already had. I guess the same list has been put up on many of these slides, and so I've got pretty much the same order. Overfishing and biodiversity loss at the top, marine pollution from sediments, and finally climate change, coral bleaching, acidification, and so forth. So I've got just a graph on illustrating the problem of overfishing, and so you can see the nicely coloured dots. So we've got green squares are the good ones, not that many of them, underexploited. Orange red ones are those that are overexploited above the sustainable output line. Black ones are those that have collapsed. And that story is depressing. It's not by any means unique to coral fisheries. And indeed, although you might think, and some of the narratives about this suggest, well, it's a case of, this isn't such a problem in Australia, which is a developed country. Most of these fisheries are in less developed countries. The fact is that looking at fisheries in general, developed countries and commercial fisheries have had almost as disastrous a record as have subsistence fisheries in important respects worse. The fishing policies of the European Union and a number of North American fisheries have been every bit as catastrophic as the figures we see here for coral reefs. There are reasonably well-developed economic policy solutions, just ones that are very difficult to implement because they require people in the short run to give up access to resources which they've exploited for some time and which they depend on. So, resilience in this concept is both important, but as far as I can determine, it certainly gets flown about a bit. And it's important in thinking about the question, given that large numbers of reefs are already degraded and that all reefs face these threats, how can we manage them in ways that achieve desirable outcomes? As I'll argue, we can't expect the system to remain unchanged, both because natural systems evolve and because as was already mentioned, systems don't bounce back to their original state in response to a shock. This notion of resilience then is the idea that we can manage that systems display desirable characteristics of returning to a desirable position after a shock, and ideally that we can manage systems in ways that improve resilience. An obvious comparison, something I've been working on for a long time, is sustainability. I used to at one point think that if you tried to catalogue the definitions of sustainability that are out there, it would be like, as I said, counting the population of China. By the time you'd finished counting the existing definitions, there would be so many more that would have appeared in the literature that the task would be never-ending. Despite that vagueness, though, sustainability has proved to be a very useful concept, and one that is now reasonably well embedded in resource management, and the vagueness in its definition hasn't prevented it from being being applied successfully. Looking over the literature, I can see two different kinds of definitions, at any rate, which I've called phase space and state space approaches, and I'll roughly speaking associated respectively with Hollings and Pym. So this is sort of the kind of picture with a phase space approach in which you're looking at a description of the position of a system that's going to evolve over time, and the notion is that this is fairly closely related, I guess, to traditional notions of stable equilibrium that economists and physicists are familiar with, but with the notion that the system can evolve over time. That means we get an equilibrium that's different from the previous one, but still recognisably in the same state. Alternatively, you can have an unstable equilibrium where you rapidly move to a radically different state, and we normally take it in the context of things like natural ecosystems that such radical moves are inherently undesirable. Economists do a lot of stuff about multiple equilibria, a lot of the time hoping to shock the system out of a low-level equilibrium, for example, one where there's a high level of unemployment, into a different and better equilibrium, and the rankings there come from our preferences. The general assumption, I think, although there's an element of that, the general assumption that we're working with here, though, is we want to keep the system more or less in its natural state, in the kind of valley that it's originally located in, not to move to some other radically different state as a result of shocks that we generate. That there will generally be a loss in a bunch of desirable values associated with that. So the second approach we see related is what I've called a state space approach, and here we think of the system as